Welcome to my channel Simple Concepts by DJ. Today we are going to deal with a numerical problem which is based on integration by parts. So let's get into the video. See, we have I equal to integral of x squared into sine cube x into dx. We have integral I equal to integral x squared into sine cube x into dx. We need to evaluate this integral using integration by parts. So what I'm going to do is, first we need to check this ILATE. So the first expression is algebraic expression followed by trigonometric expression. So this is allowed. So what I'm going to do is, before starting, I'm going to split this sine cube x into 2. That is, I will be equal to, integral of x squared into sine squared x into sine x into dx. I'm going to write sine cube x as sine squared x into sine x. So now what is sine squared x? I need to find a value for the sine squared x. For that, what I'm going to do is, this sine squared x, we know that cos 2x equal to cos squared x minus sine squared x. So this cos squared x can be written as 1 minus sine squared x minus sine squared x. So which is equal to 1 minus 2 into sine squared x, which is nothing but cos 2x. So what I'm going to do is, I'm going to change the signs. So it will be minus cos 2x equal to minus 1 plus 2 into sine squared x. Therefore, this minus 1, when it comes to the other side, it will become 1 minus cos 2x. 1 minus 1 will come to the right hand. When it comes to the left hand side, it will be plus 1. So plus 1 minus 2 cos x, 1 plus 1 minus cos 2x, which is equal to 2 into sine squared x. So now sine squared x will be 1 minus cos 2x divided by 2. So this is the value for sine squared x, right? So now this is how I got the value of sine squared x. Now I'm going to substitute this sine squared x in place where sine squared x is used. This 1 minus cos 2x by 2 will be substituted in place of sine squared x. So the sine squared x is 1 minus cos 2x divided by 2, which is equal to integral of x squared into sine squared x is 1 minus cos 2x divided by 2 into sine x into dx, So now I am going to take this 1 by 2 outside. So which will be equal to 1 divided by 2 into integral of x squared into sine x, the x squared into sine x into 1 minus cos of 2x into dx. So I am going to multiply this along with this, the term, I'm going to multiply this x squared into sine x with the term that is placed inside the bracket. So that will be equal to 1 divided by 2 into, it will be x squared sine x into 1. It will be x squared into sine x, x squared into sine x minus x squared this will be x squared into sine x into dx minus x squared into sine x into cos 2x into dx. X squared sine x into dx minus x squared sine x into cos 2x into dx. So this comes under the bracket. So what I'm going to do is I'm going to apply integral for this term that is inside the bracket. So it will be half into integral x squared sine x into dx minus half into integral x squared into sine x into cos 2x into dx. So I'm integrating half integral with the terms that is placed inside the bracket. So it will be half into x squared sine x cos 2x into dx. Now what I'm going to do is here sine x into cos 2x into dx. Now I'm going to find a value for this one. So how to find the value for this one? See, we know this like sine of x plus 2x, sine x plus 2x plus sine of x minus 2x. Nothing like this is of the form sine of a plus b plus sine of a minus b. We need to find the value of this. So it will be sine x sine a into cos 2x plus cos x into sine 2x plus sine x minus 2x of the form sine a minus b. So sine a cos b minus cos a sine b. So that will be sine a cos b, sine a cos b minus cos a minus cos a into sine b. Sattama pesadinga into sine b. So minus cos x into sine 2x, cos x into sine 2x. So I can cancel both the terms. So the remaining term is sin x cos 2x, sin x cos 2x, which is nothing but 2 into sin x into cos 2x. So I got this value like this. So sin of x plus 2x plus sin of x minus 2x will be 2 sin x into cos 2x. So what I'm going to write is, which I can also write sin x into cos 2x as 1 by 2 of sine of x plus 2x, which is sine of x plus 2 is sine of x plus 2 is sine of 3x plus sine of x minus 2x is sine of x minus 2x, which is plus sine of minus x. I can write like this, which is nothing but half into sine 3x minus sine of minus x equal to minus sine x, minus sine into x. So this is the value. So sine x into cos 2x is nothing but half into sine 3x minus sine x. So similarly sine x into cos 2x, I'm going to substitute this value in place of sine x into cos 2x into dx. So that will be So this will be half into, this is nothing but half into integral of x squared into sine x into dx minus half into this value integral of x squared into, I'm going to substitute this term. Okay, so it will be half into sine 3x minus sine of 3x minus sine x into dx. So this is the value. Now further simplifying, I'll get which is equal to half into integral x squared into sine x into dx. This half into half will come outside, so minus 1 divided by 4 into integral of x squared into, so it will be integral of x squared into sine 3x, x squared into sine 3x into dx minus integral of x squared into sine x into dx. This comes under the bracket, right? So it will be minus half into half is 1 by 4 into x squared into sine 3x into dx. So minus 1 by 4. You need to put it in bracket. So it will be, I mean, multiplying this x squared into sine x into dx minus x squared into sine x into dx. So now again what I'm going to do is, so it will be again half into integral x squared into sine x into dx minus 1 by 4 into integral x squared into sine 3x into dx minus into minus plus 1 by 4 minus into minus plus 1 by 4 into integral of x squared into sine x into dx. So this is the term, okay. So finally we have arrived into this one. So here it's x squared into sine x dx integral x squared into sine x into dx. So we can combine these both the terms. So if I combine both the terms, 1 by 2 plus 1 by 4. 1 by 2 plus 1 by 4 will be 4 2s are 8, 8, 8. So 2 1s are 2, 2 4s are 8. 4 1s are 4 plus 4 1s are 4, 4 2s are 8, 2, 6 by 8. So 2 3s are 6, 2 4s are 8. So I'll be getting 3 by 4. So I'll be getting 3 by 4 which is equal to 3 divided by 4 into integral of x squared into sine x into dx. 3 by 4 into integral x squared into sine x into dx minus 1 divided by 4 into integral of x squared into sine of 3x into dx. So this is the value of I equal to, this is the value, 3 by 4 into this term minus 1 by 4 into this term. So now what we need to do is separately we need to do integration by parts for each and every integral. So this is the value of I. So I'm going to do integral for this portion. Okay. So this will be I equal to, separately I am writing here, I equal to, see this one I equal to, let us assume that this integral will be, we'll take it as I1. This integral will take it as I2. Okay, so I need to do, I evaluate I1 and I'm going to evaluate I2. So I1 will be 3 divided by 4 integral of x squared into sine x squared into sine x into dx, x squared into sine x into dx. So now what I'm going to do is, see this one is, this term is will be u and this term will be dv. So u equal to x squared. Similarly, dv will be equal to sine x into dx. So now what I'm going to do, dv equal to sine x into dx. So upon differentiation, this will be du equal to 2x into dx. Followed by this one will be v. Upon integration, dv will be v. Integral of sine x into dx is nothing but minus cos x. Minus cos x. So now I'm going to do integration by parts. So if I do integration by parts, it will be I1 will be 3 divided by 4, and now this term will be uv, that is x squared into minus cos x minus integral of v. V is minus cos x. V into du is 2x into dx. 2x into dx. Close the bracket. So now this will be, so this will be 3 divided by 4 into minus x squared into cos x, x squared into cos x, minus into minus plus. I am taking this 2 outside integral, so it will be 2 into integral of cos x into dx. I am putting it as x into cos x into dx. Close the bracket. So now I am going to multiply with 3 by 4. So if I multiply, it will become minus 3x squared by 4, minus 3x squared by 4 into cos x plus 2 3s are 6, 2 3s are 6 divided by 4. 2 3s are 6 divided by 4 will be 2 3s are 6, 2 2s are 4. So I'll put it as 3 by 2. I'll put it as 3 divided by 2. 3 divided by 2 into integral of x into cos x into dx. So this is the value of I1. Now I have an integral here, so I'm going to evaluate this integral. So let us assume that, let us evaluate this integral. So if I integrate this integral, let it be 3 divided by 2. 3 divided by 2 of this integral, that is integral of x into cos x into dx. So now this will be, this I can take as u and this I can take as v. So u equal to x, du will be equal to dx, and dv equal to cos x into dx. So dv upon integration will be v equal to integral of cos x is nothing but sin x, v equal to sin x. Okay, so I got u equal to x and du equal to dx. dv on integration will become v cos x dx will be sin x. Now I am going to apply integration by parts. So that will be equal to 3 divided by 2 of this part upon integration by parts. I'll be getting u into v, that is x into sin x uv minus of integral v is sin x, integral v into du is dx. So this will be equal to 3 divided by 2 into x into sin x minus what is integral of sin x into dx. Integral of sin x into dx will be minus cos x. So that will be minus cos x. So minus into minus will be plus. So I am putting as plus cos x. So this will become plus cos x plus the constant of integration c. So now I am going to multiply 3 by 2 with the terms that has been present inside the bracket. So that will be 3 into x divided by 2 into sin x plus 3 by 2 into cos x plus c. So I got the value of this particular portion. Okay, this portion I have got. So my work is, what is I1? So I1 will be equal to minus 3x squared, minus 3 into x squared divided by 4, minus 3x squared divided by 4 into cos x this plus 3 by 2 into integral x into cos x dx yielded a value this. So that will be plus 3x divided by 2 sin x plus 3 divided by 2 cos x plus c. So this is the exact value of I1. So finally we got the value of I1. Okay, I1 is over. Now we need to calculate I2. Camera I2. So I1 is over. So now we need to find what is I2. So for finding I2, see, I got the value of I1 here. So let's get started with I2. So I'm rubbing this portion. So I2 will be, now we will start working with I2. So now I2 will be, so I2 here. So integral I2 will be equal to 1 divided by 4 into integral of x squared into sine of 3x into dx. 3x into dx. 1 by 4 into integral x squared into sine 3x into dx. Now I am going to evaluate this integral. So now here this one I will take it as u and this one I will take it as dv. So u will be equal to x squared and dv will be equal to sine 3x into dx. Sine 3x into dx. So u equal to x squared upon differentiation will become du equal to 2x into dx. And this dv upon integration will become v equal to integral of sine 3x will be minus cos 3x divided by 3. Okay, so I got the value. Now I'm going to do integration, which is equal to, that is I2 equal to 1 divided by 4 into, if I do integration by parts, I'll be getting u into uv, that is x squared, into v is minus cos 3x divided by 3 uv minus integral v is minus cos 3x divided by 3 integral v into du is 2x into dx, that is 2x into dx. Fine, fair enough. Okay, now what are we going to do is, we'll put it as I'll close the bracket. So 1 divided by 4 into minus x squared into minus x squared by 3 into cos 3x minus x squared by 3 minus x squared by 3 into cos 3x, minus into minus will become plus. This 2 by 3 I am taking it outside, plus 2 divided by 3 into integral of x into cos 3x into dx. So this minus into minus plus, I am taking this 2 by 3 as common out of the integral, so it will come out of the integral. So within integral it will be x into cos 3x into dx. So now what I'm going to do is, I'm going to multiply this 1 by 4 with the terms that is placed inside the bracket. So that will be minus x squared divided by 4 3s are 12 into cos of 3x plus